All right, our next speaker is Val Anderson. Val has been a professor and researcher in rangeland ecology and management at Brigham Young University for 24 years. He has worked on recovery of disturbed rangelands and improved management strategies throughout the western U.S., as well as in Africa, South America, Australia, and China. His current interests include plant material development for recovery of ecosystem function and increasing diversity while maintaining multiple use of rangelands. Please welcome Val Anderson.
Well, I'm really glad to be here today. I've learned a lot from you. In fact, I've got the elements of a lot of presentations that have been given today, and I'm going to skip pieces of those as we get to them. But I have learned a lot, and so it might even influence what I was going to say. Now, you'll notice that Scott Jensen is also a co-author with me. Scott works with the Shrub Lab there in Provo, and he's working on a PhD with me. And so anything that I say that you don't like, please attribute to Scott. And you can ask him those questions. I was pleased to hear Bryce talk so favorably about Ephraim, and how such great and hardy things only exist in Ephraim, come out of Ephraim. I came out of Ephraim. So I can withstand it here. You know, we deal with a lot of change in our environments, and historically one of the big vectors of change was grazing. Grazing pressure in the West with settlement influenced and changed a lot of plant communities. While fire has always been a factor in historical ecology, our fire regimes have changed. And the catastrophic fires that come more frequently and with more intensity have certainly affected the plant communities and range sites that we have today. Historic erosion was an issue. This is a picture from the CCs, is building terraces up on the mountains. The thing that brought Samson to Utah to figure out what was happening. Why were we getting all these wonderful mountain soils down into our valley systems? And so they were trying to fix that. But certainly that early erosion from these mountaintops changed the site productivity. And as we go through these other big disturbances, like these catastrophic fires, I've already heard people talk about horrific wind erosion that occurs. I had plots where in one storm we lost about 4.5 inches of soil because I had the stakes spray painted right down to the soil surface. And so we very carefully measure how much we lost from it. It was horrific loss. And of course, now we also deal with another disturbance of weed invasions. And this is as catastrophic as any of the others that we've mentioned. All of these affect what we might and might not be able to do on these rangelands or wildland systems. Now, reseeding is not new to us. We've had a lot of historic efforts to reseed. Early efforts, however, had two primary focuses. One was to stabilize the site, keep the soil in place, and the other one, coming off of our post-World War systems, was to increase production. And that was our major focus. We wanted production off these lands. Well, they were largely able to do that with very few species. And a lot of it was done because there had been earlier work done on these species in other places, and then early work done here. But in our dry environments in the Great Basin, crested wheatgrass and other grasses similar to that were brought in where they were adapted to the site and they could withstand some heavy use. On our higher elevation, wetter sites, things like smooth brome were included in the seed mix. I don't think any of them anticipated the smooth brome would 40 years later become the dominant in these systems and take out some of the diversity. Yet it really met the criteria at the time. They were able to stabilize the sites, and they were able to increase their production. Well, there's a changing policy relative to what we seed out. The use of native plant species as a first choice in revegetation activities is one of the things that we're generally accepting on at least our federal lands, sometimes on our state lands as well. There are exceptions. They wouldn't use the natives if the natives are deemed to be impractical, or the natives are not available. That's sometimes a big issue. Or natives are not economical, which also can be an issue currently. I would offer a friendly amendment to the exceptions that natives have not been evaluated relative to successful establishment. We just heard in our last presentation there's a high variability with things. Some things we can establish. We've got a good track record with. We've got good plant materials. Other things, we're throwing seed out there that we have no track record with, and sometimes very expensive. Well, the underlying assumption is if it grew there one time, it will grow there again if we seed it. And I'm going to talk about that assumption as we go through, because I think there's some real issues with it. Well, there's a real importance of site potential here. We've talked about restoration, and typically in our most recent times, restoration was talking about restoring back to some pre-existing plant community. But earlier times we talked about rehabilitation and reclamation, recreating ecosystem function as best possible, or reclamation creating ecosystems that provides a subset of these systems. You know, it sounds a whole lot like some of the things Cass was talking to us earlier about in terms of functional restoration, that we may be able to bring back some of the functions of these systems, and maybe it's kind of the same thoughts and theories that we had with terms like rehabilitation, reclamation. With restoration, I've always been a little bit uncomfortable with the definition of restoration being exactly duplicating what we had before, because I think a lot of things have changed from what they were before. And that may just not be realistic to go back up on that Wasatch top, that Wasatch Plateau, where we had feet of soil removed and get the same plant community back. I don't think that's possible now, unless we want to haul the dump trucks and haul the soil from the valley bottom back up and dump it on the top again. You know, and even then, the structure of the soil would be different. So I think there's some real issues. And this structural function may not look the same. You know, it may not be what it looked like in the natural environment, but it may still be the function out there. He's just looking a little bit different. Well, I think some of the questions we're going to have to ask is, where are we in our degradation system? You know, which thresholds have we crossed? You know, if we're in A here, maybe just some improved management will be able to bring us back to what we would expect to be something similar to a previous plant community. If we shifted down to B and we've crossed some kind of a biotic threshold, there may be some more major manipulation, such as seeding or some surface treatments or something else that still may allow us to cross back over that biotic threshold. But if we've crossed some of the abiotic thresholds, like significant soil loss or extensive weed invasions, or some other things that have crossed over into something else, it may take some extreme physical modifications that we're both not capable of or not willing to do, couldn't spend the money to do. And so there we may have to decide we need to design a different plant community that can restore structural function back into those systems. Historically, grazing was that real vector. But as I mentioned before, fire intensity, size, intensity, and frequency now are real strong vectors in change, and weed invasion has become maybe even a greater influence out there than either fire or grazing. Well, what have we done historically here in terms of in our recent past relative to buying seed for federal lands? This is a measure off of the BLM Consolidated Seed Buy. And if you look there, over the last 15 years, we have shifted significantly to buying more and more native seed. Sometimes as much as 70% of our buy in native seed, but typically at least 50% or pushing or above that in the native seed acquisition. And so one of the questions might be, how is that working out for us? Well, we'll talk about that in a minute. But acknowledge Tom Jones in the restoration gene pool concept, RGPs, 4 restoration gene pools, primary, secondary, tertiary, and quaternary, placed in descending order of preference to those who would restore the previous plant communities. And so the first one would be, primary, would be materials that are indigenous to a restoration site. I know a lot of times in the Park Service they want seed collected within a half mile of their site, some even more specific than that. Or seed that may be either collected directly from the site or grown under cultivation, but from those wild collections that are close to that site or in a very closely connected site, maybe something that akin to the tighter seed zone that we've talked about and so on. Secondary, they don't meet the definition of the primary. Basically, the secondary plant materials are often intended for a broader geographical use and might include these broader mixtures of that same species collected from a broader area or zone. The tertiary group, this is the group that we would typically look at as cultivars, where we've gone in and selected specifically for some traits that will help us meet some objective. All the time, one of those objectives has to be establishment. I mean, beyond that, it could be drought tolerance, it could be forage production, it could be lots of other good things. But it has to be establishment, because all those other things really don't matter if you can't get it on site. If you can't get it back, it really doesn't matter. The quaternary plant materials would be functional surrogates for species when none of the previous group would work for us. And that's probably where our introduced species that we've used broadly probably come in, or something that we would do even stronger genetical modifications with. But still, when we think about what we're going to select to put on the ground, we have to be still thinking back to the thresholds. You know, if we're looking at these bottom 2 pictures, where we might have a good portions of those native plant communities intact, we might just be able to do some surface treatments that, that modify the competitive matrix and allow for the recovery of some of the things that we would like back there. But when we have some other kinds of disturbances, where we've got, for example, heavy weed invasion tied in, or some other threshold that we've crossed through, we're probably going to have to go with things that we've selected for specific traits to help us overcome those dynamic issues. Historically, we used almost across the board adapted exotic species. Now, you know, some people might think, well, they just magically fell out of the sky, and we were beneficiaries of them. The reality of it is, it spent a lot of time and effort, a lot of scientists working to get materials that perform in these different environments. You look at all the different releases of crested wheatgrass, they took decades to develop, and they've been very, very effective. But we use them across the board. Now, we can debate whether or not that was a good idea or not a very good idea. but at the time it met the objectives. As time has gone on, we've used, the degree of disturbance was minimalized and the size of disturbance was smaller, we've used some local collections, we've used mixes and cultivars, but it certainly historically has not been at the scale that the great vast crested wheatgrass plantings and some of the forest plantings with exotic species were historically. Present use, we still use a lot. I mean, if half of it was native seed, well, guess what the other half of it was? You know, it was introduced stuff. We use a lot of it still, and probably rightly so. We've got some environments that are really tough. I don't know if we've got the native plant material that identified and tested to be able to match the challenges in some of these environments. But we're finding more and more native plant materials that we are having success with, and so legitimately we can use them. Again, probably looking at a degree of disturbance as well as the size of disturbance because of limiting factors associated with production availability and even success rates. Well, a preferred future model might have introduced species completely removed from the system if we can develop things that can take their place in terms of success. I think there are many of us who visualize a day when the size of disturbance doesn't matter so much as does the degree of disturbance. Because we have found enough material, we get it produced, that supply isn't a huge issue. And then we look at the levels of disturbances, and based on that, we become more generalized with our plant material selections to combat more drastic change in the system. Well, one of the issues, again, I mentioned it before, is plant establishment recruitment. In many of our native plant populations, recruitment is an episodic event, and it tends to be something on the level of having the climatic ideal for plant establishment, because you walk through a plant community and you'll see cohorts of reproduction, and there will be a whole bunch of this size class or this age class, and then nothing in intermittent periods, and then a whole bunch of real teeny ones, and so you'll see these classes of cohorts. Well, they came, they were recruited when you had ideal situations for recruitment. They're long-lived plants, a lot of them, and so they don't have to recruit every year. But some of them, because of the small seed and they don't persist in the seed bank, they've got to have two things happen. They've got to have a great seed year this year before the great establishment year. Now, other things that have a harder seed, they might only need the great establishment year, and so you get a more frequent cohort contribution into that plant community. That becomes, I think, one of the real difficulties or paradigm shifts in this whole system, because the way we treat land because of a fire happened, and so the next fall we go out and treat the land. We put seed out there, and we can hope and we can pray, if your faith is real strong, that you get a great year that next year. Truth of the matter is, though, as you go down in elevation in our environments here, that predictability of repeatable favorable conditions goes down. You know, historically, I've heard rangeland success in seeding success being said it's 1 in 3 to 1 in 7. Okay, and probably as you go down those elevational grids, you get down into these lower precipitation, lower predictability zones, and your success rate goes way down. So the fact that you might have a plant that's got all of the genetic tools of the whole population may still not matter in that given year. And that's where the advantage of some of the other things which have been keyed for specifically increasing the breadth of the years. They don't have to have the perfect year. They can get by and they'll establish a decent cohort in a mid-perfect year. Okay? It doesn't have to have the ideal. And so that's where some of these, the breeding comes in. There's still a real place in our systems here for identifying the traits that will broaden the opportunity here, the chance, the probability of plants having success in any given year, or at least in any given but the very worst years. Well, the dilemma of resource protection versus genetic integrity, your ideals might change if your house is the one right at the base of that hill. You may not really care that I've got a native sagebrush system out behind my house. I might rather have a crested wheatgrass field out behind my house. When the fire comes over the